Okay, welcome to BC Calc. Um, First thing I wanted you to do now, right now you do all have your phones on you. So what I want you to do first is sign up for my Remind class. So it's up here in the orange here. You're going to text to number 81010, and then the code is at 3B9F86C. If you can join the class. I think I'm also going to, if I ever send out reminders, it's usually if there's there's a test coming up or quiz coming up or help session, or sometimes students forget that there's homework over the weekend. So I'll maybe send out a reminder like Sunday to remind you, I'm going to be checking homework on Monday. Usually that's when I send out messages. I'm also going to be using Canvas more. So I'm also going to be sending out messages through Canvas as well. And hopefully between those two of them, you'll be able to see my messages. Morning, Frankie. Can you grab a packet back there? Yeah, so go ahead and do that. Make sure you sign up for my Remind class so that it's easy for me also to get in touch with you. Usually, if I need to ask you to come in for makeup or something like that, I think it's quicker and easier to be able to get in touch with students through their phone. Okay. Next up, I want to make sure that we can all access my website. So my website is mryangteacher.weebly.com. So if you guys can go there. And I also want to just walk around and make sure that you can get to the pages that I want you to see, and that all the resources that you need for this class are on the website. I also have a link to all this on through Canvas as well. So I'm trying to make it where you can go to the website directly, or if you can go to Canvas, I'll have everything laid out there as well. So if you go to, let me switch over to my other screen. Okay, so if you go to my website, it's going to take you to the AB page. And if you click on BC, that'll take you to the home page. And on the home page, you're largely going to be here in the class notes and video. I also have calendar for first and second semester here and some resources below. But if you click on BC class notes and video, and then we're going to be starting with Unit 1 limits. At the top of it, so this is where I want you to be. I want to walk around and make sure that you can get to this Unit 1 limits page. There's a calendar which is in the front back page of your front cover in your packet. This packet you do have, so Unit 1 limits packet, and there's also packet key. And this is where all the homework that I'm going to assign is going to be from the packet. So I'll be checking homework from the packet, and if you're, I expect you to check your answers on a daily basis so that you can know whether you can your problems right or wrong. And if you click on packets key, then you can, these should be lined up pretty well. So whatever the page number is assigned, you should be able to find those page numbers and packet key. So hopefully that'll make it easy where just you can trying to streamline things so that every unit is just one packet for notes and one packet for the test review or assessment review. And then if you go down to day 1, this is today, Monday, I have the syllabus link, I have the Remind join code, I have the PowerPoint slide that we're going through. And then these are basically just repeats of the packet and packet key. These are just laid out individually. And then each day I'm going to be recording video and uploading it on the website. So if you're missing a day of instruction, or if you're sick, or if you're out, just know that, by the afternoon, I'm going to have that link for that day updated. So hopefully you can go back and look at the notes, watch the video so they can catch up. So I'm hoping that this will be a good resource where you'll never feel like you're falling behind. Even if you're out, you know exactly what we did in class. Now, the videos I'm recording are, I'm really, just doing the same things as the previous year. I'm not changing much, but I am recording new videos every day for our current year. But if you go down to 2024, I have the previous year here, so you can see, this is the lesson I recorded from the previous year. So if you wanted to get ahead, you could go and watch the videos from last year, and they're very much the same. Okay, I'm not requiring you to do that. I'm just letting you know that let's say you're going to be out for an extended period, and you want to just be able to kind of get ahead. You can do that simply by going further down on the page, and you can find the corresponding day and the corresponding video. Okay, but that's just for your resource. Okay, if you can just show me that you can get to this page. Let me just walk around and show me that you can get to this limits page on your phone. And here. See. I didn't print out a syllabus, but it's on the website. You can look at it in more detail. But the grading scale majors are 55%, minors are 35%, and practice is 10%. So I'll be checking homework on most days, except for maybe the day of assessments or the day after assessments. Usually not checking homework, but your homework will just go in as daily practice. Really. Awesome. Okay. Okay, so all tests and quizzes will be closed notes. So in our class, because we're going through so much content in our time that's given to us, sometimes for certain units, I just don't have enough time to do both a quiz and a test. So for some units, we may just go and just have a quiz on that unit, or we may just have a test on that unit. So, we have a minimum of every 9 weeks, we have to do at least 2 major, 2 minors, and 3 practice. So, because they're so strict with that, I'm going to kind of follow that. There's, I'm really just trying to meet the minimum. Maybe second semester, we may have a little bit more quizzes, but in 9 weeks, just to get to that minimum, sometimes it takes a little bit of, we just have to make sure that we can get there. So, okay, so homework will be assigned daily and also checked daily. So the routine is usually I'll be walking around and just checking for completion. So you're just going to flip through the pages of the homework, and I just want to see that you've completed it. And it's really up to you to determine for you to check your answers and that you're keeping up and that you're understanding the topics. I may at the beginning of class go through some homework problems, but usually I'm starting going into the next lesson at the beginning and after I check homework. Okay, now I know that sometimes homework assignments, it may be tough to keep up with homework on a daily basis. So sometimes students are not able to get the homework done on time. And I just want to encourage you that, even if you're late on homework, still go ahead and do it. Even if it's late, the deduction is minimal. It's only 10% of the grade, but it's still important that we do our homework because, there's basically 3 points, right? As long as you attempt it, you're going to get full credit. So if you're late, you can still show it to me the next day and it'll just be a minimal deduction. Right? Okay, so this school year, there's a new county policy regarding electronics. So let me just go through that. So tomorrow, when you come into class, I'm going to have seating chart up on the wall. So you're going to find your seat number, find your seat. And then when you get to your seat, there's going to be a seat number at the top left-hand corner of your seat. And then you're going to be putting your phone in the allotted, in your assigned slot on the wall pockets there. So, and this goes for not only your phones, but any personal device. So if you have headphones, if you have earbuds, make sure you don't, I'll remind you guys each day that if you have earbuds or AirPods that you're putting them up. And also want you to put up your smartwatches as well. So either you have it up on the wall or I don't see it on you. Okay, so in the past, I would have, usually we're done with class with 5 minutes remaining or 3 minutes remaining. And usually I let students, go come up and get their phones, but they're going to be strict with this new policy now. And so you're not going to be able to get your phones until after the bell rings. So I know that's going to be some adjustment, and that's supposed to be consistent all across the board in all your classes. So we have to follow it. And, that goes for teachers as well. Teachers, we're not supposed to be on our devices either for the for the duration of instruction period. So I think that's going to be an adjustment for us. So just to let you know, that's the new county policy. And if you have any, any personal laptops, that's also not allowed as well. So you're only allowed to use Fulton issued devices. Okay, students will have opportunity to recover each test grade up to 75. This goes for major and for minor grades. And then your recovery needs to be completed before the next unit assessment. And it's not just doing corrections. You actually have to come in. Now, I will give you your. I'll try to hand back your test or quiz a week after you've taken it, so that takes me about that long to return your test. But then once you have it returned to you, you can, if you have any questions, you can go over it with me, come in for a help session, and then you'll come in and take another version of that test or quiz up to 75. Right. Help sessions. I always try to hold help sessions on the day of your test or quiz, unless there is a conflict with the AB class. Sometimes AB students also have a assessment on the same day as BC. If that's the case, then I'm still gonna have a help session for you, but it'll be the day before. Okay. I'm gonna usually have, if there's a conflict, AB will be the day of, and BC will be the day before. And it'll be 7:15 or 7:30 in the morning, depending on how much content there is. And I will record that help session. You can also come in the morning. You can also join in through Teams. And usually I will send out a remind text, like, 5 minutes before the session starts, and you can join online if you're not able to come in the morning. So, but it'll also be recorded. And it's very much the same as the help session from previous year. So you can also access the video from previous year and go through the worksheet if you want to do it the day before. So I usually have a dedicated worksheet for the test review, morning review. But if you have any questions, you want to come in for additional help session outside of the day or day before the test, I'm here by 7:15. So if you want to just come in and ask a question, want me to go over a problem with you, happy to do that. Usually I don't have any commitments in the morning. But if you want to make sure, maybe you want to text or ask me, hey, can I come in 7:30 tomorrow? I have some questions, and I'll let you know whether I have any conflicts. But I'm usually here in the morning. Okay. Textbooks. So I incorporate all the questions or the problems I want to go over with you that I want you to do in your packet. So I don't really feel a need for textbook, but I know some students want one just to have as resource at home. So it's something like this. It's a Sullivan Miranda textbook. So if you want to have one, not to bring to class, just have it at home, just as additional resource. I think in the next 2 weeks or so, Media Center should be ready. So you can just go and just check out a book and bring it home and then return it back at the end of the school year. So I don't think this is required, but if you would like one, you know where to get it at the Media Center. Check it out there. Okay, supply list. So graphing calculator is important. So hopefully you guys can all get your hands on one variation of the TI-83 or TI-84. It doesn't really matter which ones, because they're all, maybe there are ones that can do additional things, but there's only a few things that we need to be able to do with our graphing calculator. There's a couple of calculus features, and then there's graphing features. So we should have to be able to do those two, and all the 83s and 84s into it. I do have old sets of 83s, but some of the features are just takes a little bit longer to get through. But ideally, you each have your own So hopefully you guys can get one. Pacing. So if you're coming from AP Pre-Calc, first semester is just going to feel really fast. We're essentially having to cover all of AB's topics in the first semester. So we're going to go fast. So I understand, when students feel like, oh, wow, it's this is a lot to, this is a fast pace. So, especially for students coming from AP Pre-Calc, if you have any questions, or if you're stuck on anything, don't hesitate to ask, right? I think that the thing is you're like, oh, okay, maybe I can figure it out later. But then everything builds on the previous unit and it can get a little, can kind of have that snowball effect. Sometimes I have students, take a picture of a problem that they're stuck on through Remind and send me a picture and they're like, can you help me with this problem? And I'll be happy to work through a problem. Maybe you're just stuck on one concept. You either come in the morning or you can text or remind me outside of class, and I want to be able to make sure I can meet you where you're stuck. But for students coming from AB, all of first semester is review. So I think it's good and bad. It's good in the sense that you've seen everything, so nothing is new. But then sometimes the bad is that sometimes I see students who just don't put any effort because they've already seen everything, and so they end up struggling more than I'd expect. So just keep up with the topics, keep up with everything that we're doing, even if you've seen everything. So because even though you're probably not going to have to put in as much time as you did when you're in AB, it still requires you to brush up on all these topics. So I encourage you with that. At the end of first semester, we will have so at the end of first semester, we will kind of have like an overview, take like small mock tests and quizzes, FRQs for response questions involving AB topics. So that kind of feel like all the AB topics are good under your belt. And then second semester, we're going to cover the BC only topics. So we'll have a unit just over miscellaneous topics that kind of are sprinkled in involving or kind of extensions from first semester, but I'm just going to merge it all together and just call it miscellaneous. And then we have two more units after that, parametric polar vector, that is BC specific. and Unit 10 Infinite Series. That'll take a couple of weeks to get through. And then we'll be done by mid-March. And then we'll have mid-March to May to do AP exam prep. And then your AP exam is going to be May 11th. So it'll all still be a Monday. Same, similar as last year. So Monday the 11th in the morning. So second semester, it slows down, I feel, even though it's all new topics. We're just not going to do as much. And also, we're going to be done, halfway through the semester with all the new topics. So. So if you've taken the AP exam from last year, then you know the format. We have multiple choice section. That's going to be an hour and 45 minutes, 45 questions. And then true response question is 6 problems, hour and 30 minutes. You start off with 2 calculator questions, and then the last 4 are non-calculator. So the last hour, no calculator. So I say fall semester, second semester. This is really for AB. But for the first half of our fall semester, we're going to focus on derivatives, and derivatives describes the rate of change of one variable with respect to another. So in other words, this is just a fancy word for slope. So we're going to be talking about slope for the first half of this semester. And the second half of the semester, we're going to undo that derivative process. So definite integrals, integral calculus, it's involved with net change. So that's related to area. So slope and area are kind of inverse processes of each other, and we're going to just undo the process from the first half of first semester. Okay, we are going to start with notes today, but if you're just coming in, make sure that that you can join my Remind class. So 81010 is the number, and then you're going to message at 3B9F86C. So if you're just coming in, make sure that you can join that Remind. So tomorrow when you come in, you're going to look for your assigned seats. Once you're find your assigned seats, then you can put your phone up on the wall, and also just remind you guys, no earphones, and that you don't have a smartwatch. Okay, so let's move into any questions. Okay, let's move into Unit 1, limits. But first, let me just go over the calendar with you. Okay, so for each day, you're going to see your homework assignments that I'm going to be checking the next day. So we're going to be focusing on Unit 1 packet, and we're going to hopefully get through all of Unit 1 by this Friday. And then we're going to have 2 days of test review, Monday, Tuesday. And then I'm going to start Unit 2. Unit 2 is not going to be on Unit 1 test, but this kind of allows us to kind of buy some time to review. So we can start the next unit. Meanwhile, you're have some extra days to review. So there's no minor grade for this unit. We're just going to jump directly into our Unit 1 test. It'll be next Friday. So all the homework assignments are going to be in your packets. So you're just expected to work through all the problems that I've assigned. And then again, on the website, you can find the Unit 1 packet key where you can go through and you can check your answer as you're working through your homework. And this afternoon, I'll probably send you a remind just to make sure that you receive my message, and then I'll send you a link to the website as well as to the Unit 1 key, so that as you're working through your homework, you can check your answer. Okay, so page 1, we're going to start off with slope. So slope is going to be the big idea for when we talk about derivatives, but we're just going to start off with this here. Okay, so just reading with number 1 here. Mr. Brust's distance from his house is modeled by the function d of t. So while riding his bike to the store, he realizes he dropped his wallet and turns around to find it. After finding his wallet, he finishes his ride to the store. So if we kind of follow this graph, we kind of see what he's doing. So here, the y-axis represents how far he is from his house. So he starts off at his house, 0 meters from his house. And then as time passes, you can see that by 2 minutes, he's gone all the way 1,200 meters away from his house. But then this is probably when he realizes that he dropped his wallet. So then he's backtracking and he's riding his bike towards his house again. And the distance gets closer because he's backtracking along his path. And then we can probably estimate, around 6 minutes is when he finds his wallet, because he's able to pick up his wallet and continue his ride away from his house. So this most likely he reaches his destination at 8 minutes, 1,300 meters away from his house. So part A says, what is his average speed? What is his average rate of change for his trip to the store if he arrives after 8 minutes? So all we need to do is we just do slope, right? So we find out how much distance has he covered, how much time has passed, and if we divide those two, we can figure out his rate of change or his speed over that time period. So change in position divided by the change in time. So I can say this, d of 8 minus d of 0 over 8 minus 0. So d of 8 minus d of 0 will tell us how much distance he's covered. And then 8 minus 0 will just tell us how much time has passed. All right, so d of 8 is just 1,300. D of 0, his distance at time 0 is just 0. He's 0 meters away from his house. And I can do the math for us, but in the calculator, it would end up giving us 162.5. And then our units will change, right? Because this is not talking about meters anymore. This is not minutes. This is meters per minute. So on average, he's traveling about 162 meters per second. Sorry, per minute. Part B, what was his average rate of change between 2 and 6 minutes? So we can just use those as our endpoints, right? So similar to this, we just have different times that we're dealing with here. So d of 6 minus d of 2 divided by 6 minus 2. Okay, we can just set it up. The rest is just plugging the calculator, finding those the meters. And his average rate of change between 2 and 3 minutes d of 3 minus d of 2 over 3 minus 2. Is it possible to find how fast he was going at an instant? Um, yes, it's possible, but with what we have, we can probably just do a estimate. So the way we can do an estimate is we're going to find 2 points that are really, really close to each other. So for instance, if I want to find out exactly how fast he's going at 2 seconds, we can just find another point that is really close to 2. Um, and so, there's multiple ways to do this, but we're just going to be involving decimals. This is what eventually limits is going to allow us to do, where we're going to be able to find 2 points that are infinitely close to each other, and then we can find the slope to get us that accuracy that we're looking for. So for instance, if I want to find out, there's more than one way to do this, but I'm just picking a point that's really close to his location at 2 seconds. So I'm going to say that his location at 1.999 seconds. And if I do this, this will tell me how much he's traveled in that tiny moment divided by that time period. So here, this will give me a really good estimate of how fast he's moving at 2 seconds. And obviously, we can improve this accuracy even more by picking points even closer to 2. But we're going to discover that with limits and then eventually with derivatives, we can narrow that gap so that it's basically 0. So we can eventually find the slope using 1 point instead of just 2 points. And that's where the big calculus concept is coming in. So part E says, give a rough estimate of the instantaneous rate of change at 2 seconds. And just based off the table, I'm just picking 2 points that are relatively close. This is not accurate at all, but the idea is if I want to get better accuracy, I'm going to pick 2 points that are closer to each other and then find the slope rather than picking 2 points that are far apart. Number 2, we're not going to do the entire page because the bottom of the page is just basically repeating what we've kind of gone through. But number 2, it is important that we can kind of interpret what the problem is asking or what the notations mean. So B of T represents the buffalo population in the US, where T is measured in years since 1800. So then what does B of 90 represent? So we know this is 90 is representing years. All right, so this is, and so B of 90 would be in 1890. What's the population, right? The number of buffalo in the US in 1890. Part B, what does B of 50 minus B of 0 or 50 minus 0 represent? So we know this is more of a rate, right? This is change in buffalo population over the change in time period. So this is basically telling us the average rate of change in the buffalo population between 1800 and 1850. Part C, also a rate. But you can see that the time period is really, really short, between 32 and 31.1999. So what this is trying to do is this is trying to tell us the rate of change of the buffalo population at exactly 1932. Right? And this is just an estimation because we're picking points that are really close, but we know it's not exact because if we can still get a better approximation by picking a time period that's even closer to 1932. So this is a pretty good estimate of the rate of change of the population per year in that year 1832. Okay, we're going to skip the rest of page 1. You guys can finish that off later. And a few minutes here, so let's see if we can start talking about limits. So page 2. Okay, so defining limits. Limits is defined as the y value that a function or graph is approaching as the x moves closer to a given constant. So the limit is related to the y value. It's kind of similar to just looking for the y value at an ordered pair. But the difference here is the idea of approaching. Okay. And I want to specify needs to be from both sides. If the approach from both sides are not towards the same y value, then the limit does not exist. There has to be a consistent movement towards the same y value. It may not reach that y value, but there is a movement towards the same y value. Now, function value, however, is just the physical y value location on the graph. So we're going to see some distinction between function value and limits. Sometimes they're one and the same. Sometimes they're a little different from each other. So for instance, let's say this one problem that we're dealing with here. As x approaches 2, f of x approaches, the y value approaches. So here, for this instance here, you can see that the order pair, let's start with easy here. F of 2 is just equal to what? What's the y value at 2? 1. So that's just simple order pair, right? That has nothing to do with limits. But here, limit as x approaches 2 is we're looking to see what's the y value getting closer to as we approach 2. So I like to do this because I think this is a nice visual way of seeing what's happening. So anytime you see a limit approaching a number, pick 2 points on either side of that target, relatively close. Doesn't matter where, but as long as you pick points that are relatively close to 2. I'm just picking points along the graph, and I'm going to draw an arrow towards 2 along the path of the graph. So here, I'll draw the arrow up. From this point, I'll draw the arrow down. And I think this will be a nice visual connection for us because now we can ask ourselves, are the 2 arrows moving towards the same y value? Yes. Okay. They're both moving towards what y value? 1. Okay. And that's enough for the limit to exist. I know right now it just feels like, well, it's just so obvious, right? Limit is 1, f2 is 1, what's a big deal? But other times we're going to see that the arrows may point to a hole, and as long as the arrows are moving towards the same y value, that is what our limit is going to be. So here, same notation here. Limit as x approaches 2 of f of x. Again, we're approaching the x value of 2. Pick points on either side of 2. And then draw an arrow towards 2 from each of those starting points. Are the 2 arrows moving towards the same y value? They're both moving towards what? Also 1. Even though the point doesn't exist, the arrows are consistent. If the arrows are consistent, it doesn't matter what's happening at that point. You go with what the arrows are telling you. Okay. Now here, f of 2 is equal to what? Is there any point to find? No. So this is undefined. So we say undefined. So the point doesn't exist. Or you can say DNE, which is just an abbreviation for does not exist. Either is fine. You can do one or the other. Okay, third example here. Limit as x approaches 2. Again, we're approaching 2 from both sides. So I'm going to pick points on either side of 2, relatively close. Draw an arrow towards my target. Are the 2 arrows headed towards each other? Yes, they're both headed towards 1. Okay. But f of 2, where's the point defined though? At 3. So I think this is where I see some students get thrown off a little bit, where they see the arrows here, but then they're distracted by that point. So just know that the limit is where the arrows are telling you, and the point is just wherever that single point is. The order pair doesn't care what's happening around the graph. The limit cares more about what's happening around the graph. Okay, let me draw one more here. This is one example that I didn't see, so I want to just draw this one here. So I have one graph headed towards 2, 1. And I'll have another graph at 2, 4 with a hole there. So 2, 1 and 2, 4. A point here and a hole up here. So this is my next example I want to show. So let's do this. Limit as x approaches 2 of f of x versus f of 2. Okay, limit as x approaches 2. Again, we'll do the same thing. Pick points on either side of 2, relatively close, plot them, or indicate, and then move along the path of the graph towards 2. So this point is headed towards that point, but this point is headed towards the hole. Now, the question is there a consistent movement of the arrows? No. So this is where you say the limit does not exist. Okay. If the arrows are pointing to the same y value, regardless of whether it reaches it or not, that is where the limit is. But if the arrows are not pointing to the same y value, then limit does not exist. So we say D and E. Now, f of 2 is a point existing at 2. Yes, right. F of 2 equals what? 1, right? This 1 is where the point is, not the hole. So f of 2 equals 1. Okay, your homework is pages 1 through 4. Try your best through the problems. And you have the key. I'll send you guys the key tonight so that you guys can check your answers. So your homework assignment tonight, pages 1 through 4 all. Okay, we're on C schedule today, so we're going to go to second period, and then homeroom is going to be with your second period. There'll be homeroom all week this week.
Oh, just whatever your second period is.
Yes,
They didn't change it last year.
I believe so.
Sorry. And then like your
Right.
And SSS, right?
no.
Oh, wow.
Oh, yeah.
Yeah, I think that.